Hi everyone. Today we're going to be talking about the product rule of exponents, and there's a couple of rules for exponents, and we'll go through each one in different videos. But the product rule says that if I have the same base or the bigger number or variable, and they have two different exponents, and I'm multiplying those two things together, I actually add the exponents together. So the succinct way to put it down is x to the power of a times x to the power of b is the same thing as x to the power of a plus b. So a good example, like with actual numbers, would be x to the power of 2 times x to the power of 7 is equal to x to the power of 2 plus 7, which is the same thing as x to the power of 9. So that's the product rule of exponents. Let's go through some examples, and that way you can see a few more. So the first example is x squared times 5x to the fourth. So on this one, it looks really similar to that example that I just wrote up above, but it has that 5 in front of this one, this 5 right here. And if the x squared had a number attached to it or a coefficient attached to it, we would multiply those things. But because it doesn't have a number attached to it, we're just going to rewrite the 5. And then you have the x squared and the x to the fourth. Now, based on this product rule, that's the same thing as saying x squared or x to the 2 plus 4, which, if I simplify that, I end up with 5x to the 6th. And that is my final answer. Okay, let's go through another example. This example is 4x cubed times 2x to the 5th times 3x. So remember what I said in the first example. If I had another coefficient, I'd multiply them. In this example, we have 3 coefficients, or these numbers that are in front of our x's. So we're going to actually go through and multiply them. So you're going to have 4 times 2 times 3, which gives me 24. So then we're gonna do our x's. So we've got x to the third, x to the fifth, and x. This x right in the very last one, even though it doesn't have an exponent, we can make it an exponent of 1. And so that way when we use our product rule, we're gonna have x to the power of 3 plus 5 plus 1. It doesn't matter how many we have. We could have 100 different exponents that we add together as long as they have the same base. So these all have the same base as of x. So we can add them all together. So simplified version of that is 24x to the power of 9, because 3 plus 5 plus 1 is 9. Okay. Let's go on the next example, the third example, which is 5x y cubed times x squared y cubed. In this case, we only have the 5 as a coefficient, so we know we're going to start with 5. Then you have x's and y's. So we're going to add the exponents for the x's, and then we're going to add the exponents for our y's. You're going to have, for our final answer, you'll have an x portion and a y portion. So for this first one, 5xy cubed, this is really x to the first. So I can write this 5x to the first plus 2, because the other one has x squared. And then for our y's, we'd have y to the power of 3 plus 3, because both of them are y cubed. So when I simplify that, I end up with 5x to the third power, y to the 6th power, and that is my final answer. Okay, let's go through one more example, and this one, of course, is the most complicated, but it still uses the exact same rules. So we have 4x squared yz cubed times 5xy times y squared z to the 5th. So the first thing I'm going to do is multiply the coefficients that we have, so the 4 and the 5. So 4 times 5 gives me 20. I know that my final answer will start with a 20. Then we're going to look at our x's. So the first x is x squared. The second x is x to the first power, so I'm going to say plus 1 right here. And then the third portion doesn't have an x, so I can just leave it like that. Then let's talk about our y's. So our first portion has just a 1y, so we can put a 1 there. Then our second portion just has 1y, we can put a 1 there, and it'd be 1 plus 1. And then our third portion has y squared, so we put a plus 2. And then for the last portion, we have z's. And for the first chunk, we have z to the third. The second chunk doesn't have any z's, so we don't have to write anything. And then the third chunk has z to the fifth, so I'm going to say plus 5 right here. When I simplify, I'm going to end up with 20x to the third power, because 2 plus 1 is 3. Y to the fourth power, because 1 plus 1 plus 2 is 4. And then z to the eighth power, because 3 plus 5 is 8. And there we have it. This is how we do the product rule of exponents.